Hello and welcome to the Conner Equation Part 3. We're going to start off with reviewing a little bit of the basics. We are, of course, splitting polygons into trapezoids, vertical trapezoids, adding up all the areas of all the trapezoids to get the, and subtracting the ones with negative area, of course, to get the total and perfect area of the polygon. Let's review area of a trapezoid. It's B1 plus B2 in parentheses times the height over 2. Of course, you guys know that pretty well. Now, here's the thing. In our thing, we're working with vertical trapezoids. And with vertical trapezoids, H stands for height. But of course, the H in this context, these are our parallel sides. H is this, okay? Now, and that's kind of maybe confusing, inconvenient. B1, I don't know, you would choose one of the ones to be B1 and the other one would be B2. So we're gonna actually erase this. I'm going to rewrite it. I'm going to say AT and I'm going to say AT alpha equals, and we're going to do, instead of B1 and B2, I'm going to do HB, trust me, this will work, plus HC, and then this will be B over 2, okay? The reason why HB, that's going to be our kind of first, we're going to imagine these are the heights. That will make it kind of easier for people to follow. B, that stands for base, okay? I hope that's, obvious, or I hope that's clear, sorry. Now, of course, HC, by the way, height, remember, going clockwise around the polygon, right? So this would be, HB and then HC, and then again, for the next side, this would be HB, this would be HC, going all the way around the polygon, okay? So now, before I erase it, this is B. Sure. This side will be, this would be HB, and this would be HC. Let's focus on calculating the B part, okay? That, the horizontal aspect of the side. Okay, so to do that, we want to get these trapezoids to have those lines be actually parallel to each other, and then each trapezoid perfectly fits with all the other trapezoids. We of course gotta use phi n instead of theta n. We gotta use the angle relative to the positive x-axis. Really, we got to use an angle that's relative to an axis that all the angles have to be relative to the same axis, basically. In this case, we're just going to say this is the positive x-axis right here. So this, by the way, would be phi 1. This is phi 2. I'm not going to draw it, okay, because space reasons, basically, okay? Now, to get the base of the trapezoid, we're calling this the base now, okay? To get this length, of course, we want to take the cosine. We want to do, it's going to be the side length we're on times the cosine of phi n, and that will get us this, the base. And of course, for all of these, right? So for this one, I'll draw this, relative to the x-axis. The base is also going to be, it's going to be parallel. Basically, the heights are perpendicular to the positive x-axis, and the bases, they're parallel to the positive x-axis. So let's do it. I'm going to say B alpha. I'm calling it alpha for kind of superficial reasons, all right? So this is what this means, all right? So the first side, remember the first side is this one. The first angle is this one. So this is theta 1, it's also phi 1. This is SL1. This is SL2. This angle is phi 2, okay? And you just keep going all the way around the polygon, all right? So base 1 would be, you see that? You see how it's going that way? That is base 1, all right? It's actually going to be a negative value. Watch. Oh, sorry, in this example of a polygon, it's a negative value. It's not always a negative value. All right, so whatever the base number is, it's going to be equal to SL, okay, I'm going to say K here. Okay, it might get a little confusing. Really? This is what I'm going to do. I know it's confusing. Bear with me. This is actually phi K in reality. Why is this? It all has to do with summation notation. I can't, summation, it'll mess up the summation notation. I would love for everything to be n. So theta n, phi n, SL n, B n, just make it all n. It all makes sense, when n equals 1, you're looking at, of course, base 1, and you're looking at side length 1, and all that. However, it messes up the summation notation. Okay, so I can't, and I don't really have time to, I'll in a later video, you'll understand why it'd be a big problem if I had everything with the same letter. I would love to do that. I can't do that, okay? So this is how it's going to be, okay? This is it, okay? So base alpha, interesting, equals side length K times the cosine of phi K, okay? That, in essence, is pretty much it, okay? Now, this is not in an ideal format. For instance, what is phi K? What is it? Yeah, good question. Good question. And how is this going to work with summation notation? Guys, okay, bear with me. Just bear with me. Base alpha equals, we're going to use summation notation. We don't need summation notation necessarily. We just, for the trapezoid, that's an ugly trapezoid. For a trapezoid, you don't need to add the bases. You don't need to add the bases as you go clockwise around the trapezoid. Of course not. You need to keep track of the heights. Yeah, the height is changing. And to keep track of that, we are adding and subtracting heights. But in order to, we're simply, believe it or not, we're simply using summation notation here to transfer from alpha into K. Because the heights, right, are HBs and HCs. They use SLK. And so, and they actually need summation notation. So they need that alpha to K kind of transformation. And so to be consistent, to make everything work, we have to do the same thing here. We have to, okay? We're going to start with alpha on the top, okay? And we're going to say K equals alpha. SLK times the cosine. Now, bear with me, okay? Remember how I asked the question, what is phi k? This is what phi k is, okay? Phi k, just bear with me. Okay, so we got k minus 1 times pi. Okay, remember, phi, it's 180 degrees or pi, if we're dealing in radians, which we probably should, you know, plus the previous phi, plus the angle, the interior angle, okay? And to transfer this into something we can use, this is what I'm doing, okay? It's simply what I have to do, okay? Plus summation notation, okay? We're going to put n equals 1. Our starting point is 1, the first phi, and then this is k, and then it's just going to be theta n. And we're going to close the parentheses. That's what we're taking the cosine of. The reason why we're doing this is so we need to do this in order to get the correct phi value, okay? Should I go over a kind of example? Fine, okay. So, you know, n equals 1. The angles, we are adding the angles. Remember, this process is a continuous process going clockwise around the polygon. So, oh no, it's right there. Okay. So we are adding the angles here. Now, the 180 degrees, every other angle, it cancels itself out because you're adding 180 plus 180 is 360, and it makes you didn't even need that. So that's why we have the k minus 1 here. On our first angle, you know, on our first side, 1 minus 1, k is going to be 1, so 1 minus 1 is 0, so that's just 0. And 1, n equals 1, that, you know, we remember theta 1 equals phi, please. Phi 1, that's it. So this is it right here. This is, I hope you could understand why we're doing this, okay? Why we're doing this, this is the way we kind of have to do this in order to make it work to make everything work in harmony, because remember, this is just the base. We have to do the same thing, that'll be in the next video, for the heights. I know it's going to be daunting. It's a big formula for sure. All right, that's going to be it for this video. Bye.